Okay. Well, we presented the kettle reboilers. Now we have seen the vertical thermosiphon recirculating. And the next one, we saw the advantages and drawbacks of the natural circulation vertical thermosiphon. And now we are gonna see another type of natural circulation vertical thermosiphon once through. In this case, a reboiler where the liquid comes from the column and is heated only once is called once through vertical thermosiphon reboiler. In this case, as you can see in the sketch, the feed, the exchanger inlet comes from the side of the column instead of the bottom, as it was in the last thermosiphon we saw. And it goes straight once to the thermosiphon, to the tube side. It goes up and it enters again into the column in form of vapor and liquid. And then the liquid that drops down to the column is the feed that is not again introduced in our thermosiphon. So all the liquid from the bottom tray flows to the reboiler, this one. None of the liquid from the bottom of the tower flows to the reboiler, and all the bottom's product comes from the liquid portion of the reboiler effluent. When the once through thermosiphon reboiler is working correctly, the reboiler outlet temperature, this one, and the tower bottom temperature, this one, are identical. Here I want to put just next to the once through thermosiphon the picture of the sketch of the last vertical thermosiphon we have seen, the recirculating thermosiphon, just to show you the main difference, that in the recirculating thermosiphon, we take the bottom of the column to the thermosiphon, and then this liquid, the liquid part of the thermosiphon goes down again. So this is recirculating all the time. In this case, it only flows once, and it is not recirculating because this liquid is taken from the bottom as the feed. And in this last slide of the vertical recirculating, of the vertical natural circulation reboilers, I want to summarize the three types of reboilers, of vertical reboilers, of reboilers we have seen, because the kettle is horizontal. So we have seen the kettle type, the vertical natural recirculation, and the vertical once through type. Here are the advantages and disadvantages of each one. So just remember, for the kettle type, the ease of maintenance, the vapor disengaging that allows to have here 100% vapor, the low skirt height for the column, since we do not need to have the column above the heater, the ease of control, and no limit on vapor load. And the main disadvantages, the extra piping and space due to the size of the exchanger, the high cost, again, due to the size of the shell, and it fills with dirty fluids because velocities are lower than for vertical thermosiphon. So then for the vertical natural recirculation, the second one we have seen, it is simple piping and compact, has lower cost than kettle. As disadvantage, it falls easier than the vertical ones through type, sorry, not that the kettle one. The difficult maintenance because it does not allow to have high delta temperature, so we have to add an expansion joint. And the high skirt height we need to have on the column to have it usually above the thermosiphon. And for the vertical ones through type, is not easily fooled, lower cost than kettle, but we also need to have a high skirt height and there is no control of circulation. So now we have seen the natural circulation reboilers, the vertical ones. And now we are gonna check the horizontal thermosiphon. The horizontal thermosiphon reboiler is horizontally mounted shell and tube exchanger with the boiling fluid on the shell side and the heating fluid is inside the tubes. Remember that for the vertical thermosiphon, the boiling fluid was located inside the tubes. Here on the horizontal, the boiling fluid is located on the shell side. So then we have the bottom of our column flowing into the shell part where it vaporizes and enters the liquid mixture, vapor, and liquid into the column again. The thema used for these types of horizontal reboilers are X, G, or H, depending if we need to have just one nozzle, we will use a G type. If we need to have more nozzles, more outlet nozzles, we will use X or H type. The liquid from the column passes in cross flow over a tube bundle, and the liquid vapor mixture is returned to the column. This design has the advantage of preserving the natural circulation concept while allowing a lower headroom than the vertical thermosiphon type. So here, our liquid static head will be lower than on vertical exchanger because this height is lower than for the vertical thermosiphon reboiler. However, there are more uncertainties about fouling and about the prediction of the cross-flow heat transfer. It means that here, since our boiling fluid is on the shell side, the velocity on the shell side will be lower and will be more likely to foul. So the main advantages of the horizontal thermosiphon are the exchanger is relatively cheap, more than the kettle reboiler, because the shell is smaller than the kettle. We can have more than one pass, so multi-pass arrangement for the heating fluid can be used, so no thermal expansion can be accommodated. It means that here we can have more than one pass As for example, in this sketch, we have two tube passes, one pass here and the other pass here. So thermal expansion can be accommodated. We can use removable bundles. So this is very useful to clean the tube bundle. High circulation can be achieved, leading to high heat transfer coefficient and low fouling. High circulation can be achieved according to the kettle reboiler, but with vertical thermosiphon, we have still a more higher heat transfer coefficient than with the horizontal thermosiphon. And the elevation of the column is less than for a vertical reboiler. As a drawbacks, we have larger plot areas required than for vertical unit, especially if the tube bundle is removable, because we need to let space to pull out the bundle. The process fluid is on the shell side, creating potential problems with fouling or corrosive fluids. So then, if if we have a corrosive or fouled fluid, we will try to install this fluid on the tube side. So we prefer to use vertical thermosiphon instead of horizontal thermosiphon. Okay, this is if someone has, because now we are gonna pass to another type of reboiler. So if you have any question regarding this type of thermosiphon, please just let me know.
Thanks Olga. شباب احنا عندنا سؤال استفسار على الناتشرال سيركيليشن بانواعها. يعني كلها واضحة؟ ما حد أي واحد عنده استفسار؟ Okay. I think it's okay. Sounds okay. Good.
Okay.
Thanks.
You're welcome. So now let's gonna see the internal, also called bundle in column reboiler. Internal reboilers are also known as step-in reboilers or step-in bundles. They are another special application of the horizontal reboiler design. The internal reboiler is used where the process can be on the shell side and the reboiler surface area is small enough to fit into the distillation column bottom sump. Boiling takes place in the pool of liquid at the bottom of the tower, and the heating fluid goes inside the tubes of the tube bundle. So as you can see here, the heating fluid goes into the tubes. We have U-tubes, and here it goes out. And the fluid we want to vaporize is starting the bubbles here inside the column. And here we achieve the amount of vaporization we want. Since the boiling liquid forms foam, which may vary in density, controlling the bottom level can be difficult. For that reason, this exchanger is not very common for vacuum services. The main application for internal reboilers are for batch distillation, where the tube bundle can be easily fitted into the batch drum and periodic cleaning can be easily done. For very low heat duty clean services, and it is meant low heat duty because the column diameter is shall be large due to other considerations, and the reboiler tube bundle shall fit into the column. So because usually one of the main restrictions to have an internal reboiler is to fit this tube bundle and to have enough space into into our column diameter to fit our reboiler. So these reboilers have the limitation imposed by the size of the distillation column, because the diameter of the column establishes the length of the tubes. So the main advantages of internal type reboiler are the no thermal expansion issues, since the tubes we use are U-tubes. They have a very low cost since there is no shell construction. The separation efficiency of the boiler approaches one theoretical stage. But as drawbacks, we have the heat transfer surface limitations. It is usually only used with large diameter columns, and it is not recommended for vacuum services since it is difficult to control due to the foam it gets the bubbling, the vaporization. Okay, so up to now, we have now finished the natural circulation reboilers, and we will talk about the forced circulation reboilers. So if you have any question regarding these natural circulation reboilers and more about this last one, the internal thermosiphon, please let me know.
I think you can proceed. I don't see any questions.
لا أستاذ أحمد بس سؤال واحد.
There is one. تفضل مصطفى.
سلايد 26 اللي قبله.
If you go back to 26, thanks. Yes.
Yes.
أستاذ بس النقطة الأخيرة يعني ما شنو لامينيشن يعني هنا ما فهمت صراحة.
limitation يعني محدود يعني انت هذا الخيار اذا انت تختار تخلي الريبويلر بداخل التور راح تبقى محدوده الى عامل مهم وهو الحجم الديستليشن كولوم مثلا اذا هذا ديستليشن فيعني اذا الحجم ما يكفي بعد ما تقدر تروح لهذا الخيار هذا القصد يعني
يعني لازم نفس النقاط السابقه لازم الكولوم كبير
بالضبط فيعني الريبويلرز have the limitation imposed by the size of the distillation column يعني انت حتى اذا هذا خيارك من ناحيه فنيه زين بس من ناحيه ميكانيكيه ما تقدر تسوي لانه مثلا اذا طول البندل مال التيوبس اطول من القطر مال البرج ما تقدر تدخله بداخل الكولوم هذه الفكره يعني هذا
يوسف هذا عندنا برج البرافان والدراير مال البرافان الاوبريجي مال عندنا بينات المطروقات
نعم
برجين صغيره الباندل كل صغيره
بلي اي لا بس هو كخيار بالتصاميم يعني اذا انت ما
يعني محدود
القطر ما تقدر تروح هذا الخيار بالضبط.
ممنون
شكرا استاذ مصطفى.
يعني فارنج يصير عليه مباشر يعني دائما تتلوث
بلي
مباشر ماكو شيء ماكو
اي صح صحيح شباب احد عنده سؤال او استفسار؟
العفو أستاذ، بس السؤال بعد واحد ولو
لا بالعكس، لا بالعكس.
بس هنا أنا يعني إذا صار شلون مثل ما تقول فد ليكج بي، يعني شلون هنا يعني هذا ممكن يطلع كله، لو شلون الصيانة ما
طبعا راح يصير، راح تلوث اذا يتلوث، اذا هو شيء كريتيكال يعني.
هو يقول الصيانه ابو يوسف، هذا ينسحب ابو يوسف الربط داخل البرج
بلي.
عن طريق يعني رينج ماكو نوز منهول، وهاي تدخل به الباندل بها
بلي.
يعني
تنشد
ممكن
داخل بناتين، هذا ينسحب يعني يتفحص او يتبدل ويرجع بداله. بالضبط هيتر مال جيزر، هيتر مال جيزر ماكو
نعم
سخان،
نعم نعم
نفس الفكره
بالضبط نفس التطبيق، نفس
أوكي.
التطبيق نفس الفكره بالضبط، ينسحب يتبدل ويرجع او يتعالج.
رحم الله.
شباب بعد ما حد عنده سؤال استفسار؟ تقريبا احنا 38 واحد ماكو حد عنده سؤال؟ Okay, sorry, Olga, you can move to the next section, I guess. Thanks.
Okay, you're welcome. So yes, we have talked about the natural circulation and forced circulation, and we're gonna talk in once about the vertical and horizontal heat exchangers. So forced circulation reboilers are similar to vertical and horizontal thermosiphon reboilers, except the pump is used for the circulation of the liquid rather than relying on natural or thermosiphon circulation. They are usually designed to operate liquid full, and flushing occurs as the liquid crosses the control valve, which is located close to the column shell. They offer great operational flexibility because the control of the pump and also the footprint is small because in this case, for the vertical one, we have, it is only the reboiler diameter we have to consider, and for the horizontal, the footprint is smaller than considering a kettle. The main use of forced flow reboilers is in services with severe fouling problems and or highly viscous, greater than 25 centipoints, liquids for which kettle and thermosiphon reboilers are not well suited. So when we have fluids with severe foulings and highly viscous, we will use the forced circulation reboilers because the pump allows to circulate our fluid and to have higher velocities than to reduce the fouling problems. So the main advantages of the forced circulation reboilers are good circulation, resulting in good heat transfer and reduced fouling. There is less likelihood of instabilities than natural circulation thermosiphons. We have smaller diameter pipe work because since right now we are using a pump for circulating the fluid instead of letting the thermosiphon with the pressures to circulate, we do not care about how much pressure drop we are losing. So the piping can be lower with forced circulation reboiler. And finally, the exchanger does not need to be located close to the column. So there is no need for the column to be above the boiler because we have the pump who is pumping, let's say, our fluid into the reboiler. As drawbacks, a pump is required, so this adds cost to our process. Also, the boiler does not contribute a full theoretical stage to the separation, as for example, the kettle it does. And these are just the two drawbacks we have. So this is the last slide about the type of reboilers, the forced circulation. So if you have any question about this type, please just let me know.
العفو استاذ احمد.
ايه تفضل استاذ مصطفى.
استاذ بس هنا الفلو مال الماده اللي جاي يسوي لها سيركيليشن هنا انا اتحكم بها بالكنترول فالف لو البامب بها سبيد ليميتيشن يعني.
لا مو سبيد ليميتيشن بالضبط، هو كنترول فالف اكو، بس هو اللي يعني ضغط المائع او الفلويد جاي من المضخه، يعني ما تنتظر انه لازم عندك ستاتيك هيد يعني وعمود السائل لازم يكون بارتفاع معين حتى تضمن انه الجريان يصير من الكولوم للريبويلر. بسبب وجود المضخه، هي المضخه تعطيك الضغط المطلوب، لذلك عندك حريه بمكان الريبويلر وين تخليه، ما عندك مشكله بالبريشر دروب لانه المضخه هي راح تعوض.
اوكي استاذ زين. بس سلايد 28 اللي قبله.
Olga, sorry, if you go back to 28.
Yes.
Slide number 20.
Yes.
استاذ هنا يحكي على هنا هاي ريسبكت، يعني هاي اللزوجه هنا عاليه greater than 25 سي. شنو هاي السي بي؟ ما
السي بي السنتيبويز اللي هو وحده قياس اللزوجه.
فاهم.
سنتيبوز هاي فرنسيه.
ايه
اوكي.
اكو سنتي ستوك واكو سنتي بويز واكو اللي هو الاس اي اللي هي ما اتذكر كيلوغرام على سكند متر مربع الصور.
اوكي ممنونك استاذ.
شباب ما حد عنده سؤال استفسار؟ البنات ما حد عنده سؤال استفسار؟ ماكو حد عنده سؤال. اوكي Olga, you can carry on. Yeah, thanks.
Okay, thank you. So there are many factors in this four point. We are gonna see the reboiler selection. So there are many factors that we consider to select one type or another type of reboiler. And here,
so sorry, you finished the two types now, yeah, the forced and the natural, and now we're talking about the how we select, yeah, how to select the type of the reboiler, right?
Exactly. Yes.
Oh, thanks.
So the most common influencing factors for the reboiler type selection are fouling. High fouling fluids are located on the tube side because it is easier to clean than the shell side. So then we will want a reboiler where the boiling fluid is located inside the tubes. So for fouling fluids, we cannot consider here horizontal reboiler or kettle, and we will prefer to have vertical thermosiphon to place this full service on the tube side. Then we also consider corrosion. Corrosion, we will follow the same, let's say, rule as the fouling. Corrosion issues may dictate the use of expensive alloys on the tube side or shell side. Therefore, these fluids are placed inside tubes in order to save the cost of an alloy shell. Also, the pressure, high pressure fluids are placed on tube side to avoid the expense of thick-walled shells. Temperature, very hot fluids are placed inside tubes to reduce shell cost. the lowest stress limits at high temperatures affect shell design the same as high pressures. And finally, the space constraints. The allowable space can dictate the use of vertical, horizontal, or internal reboilers. So these five factors we take into consideration when choosing our right reboiler. And in this scheme, you can see a quick approach of which type of reboiler is better to consider according to some parameters. This is just an approximation, and of course, each case is different and each case needs to be analyzed according to the plant and the industry we are, and also the references we have with the same service. But this scheme is a good start to see which type of reboiler fits better our design. So this scheme considers which is the vaporization rate we want to have, also the process fluid characteristics as the viscosity of the fluid, and also it considers the estimated area, or if we have, or if we can use a bottom pump. So we would start here. We will ask ourselves if we want a higher vaporization of 30%. If no, let's go to the yes. If yes, we ask ourselves if we have high viscosity. Here it is put 2 centipoise. In this case, we talk about 25 centipoise. 25 usually is like the maximum viscosity we can do with a natural circulation thermosiphon. In this case, as a start, we would start with 2 centipoise. And if viscosity is higher than 2 centipoise, the thermosiphon recommended would be the forced circulation reboiler. Of course, then, if we select forced circulation reboiler, we will need to check if we have enough space to locate the bottom pump. But at least to start, we can start having and thinking that the forced circulation is the better reboiler that fits our process fluid. If the viscosity is lower, then our next question is if the estimated area is big or no. It's bigger than 60 meters square, or if it's lower. If it is bigger than 60 meters square, we would go to the kettle reboiler. And if it's smaller, we can go to the horizontal thermosiphon. Kettle reboiler, remember that we had better control at turn down conditions. So our control, it is better when we have big exchangers. Otherwise, we can go to the horizontal thermosiphon, because it is, in this case, if the area is not a constraint, with horizontal thermosiphon, we avoid having this big shell that we have with the kettle reboiler. Also, if vaporization is lower than 30%, 35% actually, we ask ourselves if there is a bottom pump. If we do not have a bottom pump, we ask ourselves if the tower can be elevated. If the tower can be elevated and the viscosity is correct, is right, is small, the tube length and the area in this case is not too big, we can go to the thermosiphon reboiler. Why this question? Why tube length if tube length is lower than 6 meters? Because remember that since we have to elevate the tower, we want to avoid as much as possible having a long tubes for the vertical thermosiphon to elevate as less as possible the tower, because elevating the tower is equal to have more cost on the skirt of the tower. So this is a quick start to see where we are according to our service, according to the vaporization we want to achieve, and also according to the area we have available in our plan for the selection of the correct thermosiphon. So this is the end of the reboiler part. Please let me know if you have any question.
Yeah, sure. So basically, on as a comment on this slide, basically there are around like 7 criteria we follow, or 7 blocks here, obviously.
Yes.
To decide which, and there is a a logical sequence to follow. Then we decide which type of reboiler we go with. Yeah.
Yes.
Yeah. Thanks.
Later, of course, there will be some discussion. This is actually a start, and then we will need to have more discussion when we have pre-selected, let's say, one of these reboilers, and we start to design the reboiler.
Sure, but the question that on this block is when we start the logical or logarithmic sequence. What's the vapor percentage I know in my hand to decide whether it's 30 or not? Is that something is desirable, or how do I know I need 30% vapor, more or less?
This is actually this is something very, very common, that our vaporization rate is always between 25 and 35% for all distillation columns. So this is a standard.
Okay, so it's a standard value. So we start 30. Yeah.
Actually, the main difference is when we have regular reboiler, which allows to have these 20 or 35. It depends also of the nature. Mainly, if we only have water, it will be 15%. But this is like standard numbers for depending on the nature of the fluid we are vaporizing.
Yeah, sure.
For water is maximum, I think, 15%, but for hydrocarbon is between 25 and 35. So this vaporization rate will go for, okay, I need a thermosiphon, or there are some other cases that for vaporizers, for example, we will go for kettle reboiler, because what we want at the outlet is having 100% of vapor. We do not want a mixture of liquid and vapor. So when we want just 100% vapor, we will go for kettle reboiler.
Yeah. So like a decision that made, then you go straight to the last choice. Yeah, because you need 100%. Yeah. Okay. Thanks, Olga. Let's see if
You're
we
welcome.
I think I have a few questions in the private chat. Okay, let's start with the verbal questions. تفضل أستاذ مصطفى علي.
وعليكم السلام.
السلام ورحمة الله على أستاذ.
أستاذ بس هذني البلوكات الاثنين اللي تقول كان تاور بي elevated، يعني شلون احدد ان هذا التاور اقدر اخليه على ارتفاع معين؟ شلون احدد ان هذا التاور اقدر ارفعه او ما اقدر ارفعه؟
بلي طبعا هو
قبله شلون اقدر اعرف انه مثلا هنا أنا اقدر اخلي بم او ما اقدر اخلي؟ شنو اللي يحدد؟
هو شوف، يعني انا راح اجاوبك وهم نسالها، بس انت بشكل عام اذا المشروع جديد مثل كربلاء بالتصاميم الاوليه للمشروع انت تقدر كل شيء تسوي، باعتبار لان لم مشتري المعده ولا منصبها، والارتفاع البرج او ارتفاع الفزل عندك اياه ممكن تتلاعب به حسب حاجه البروسيس. تفهم قصدي؟ بس اذا انت مبني وتسوي مثلا ريفامب اللي هو اعاده تاهيل، تصير صعبه، لانه انت تحكي كذا 100 طن انت تعال ترفع وتغير فاونديشن، فالقصه شبه مستحيله يعني. والمضخه قلت لك هم نفس الاجابه تقريبا، انه اذا انت شيء جديد تصممه تقدر تضيف اذا تحتاج او ما تضيف، يعني حسب الحاجه او حسب السيكونس.
ابو يوسف،
تفضل استاذ
ابو يوسف، يعني ارتفاع البرج بالنسبه للريبويلر
بلي
هو يقصد ارتفاع المستوى على مود مستوى مال الليفل داخل البويلر داخل البرج عن الريبويلر. فهو اذا في حاله الافقي يعني أو الافقي والناتشرال لازم انت متحدد بارتفاع الليفل داخل البرج، لازم تتحدد.
لا بس اسمح لي، احنا راح نرجع نسال
اذا فورس تختلف.
ماكو خلاف بس القصه شنو؟ اسمح لي مو بس موضوع الريبول، هذه القصه ارتفاع البرج نفسه وليس الدواخل.
بالضبط. اي مو ابو يوسف، انت اذا خليت كتل لازم تصعد البرج فوق اساس،
بس
على مود تضمن ارتفاع البرج عن البيس، يعني عن الزيرو بيس. شايف الزيرو بيس من ياخذون القطاع يعني الوحده، يعني خلينا نقول البيس مال الوحده، فيضطر شو يسوي اذا جاب كتل؟ يضطر يرفع البرج على اساس عالي.
اي بس هاي
هذا راح يرفع البرج.
تسويها يعني هسه انت برج التقطير عندك مثلا انبنى هسه، انت ما تروح تقدر تقول اي كان
يعني ممكن. مو احنا هاي تخص بدايه، احنا بدايتنا بالستارت بعد يعني.
لا ما ممكن انت صارف ملايين الدولارات، شلون تقدر ترفع؟ زين ولا نبي
اسالها. لا مو بالمبني، قصدي بالجديد.
الجديد اي طبعا. هو انا احكي جديد. انا اول اذا انت سمعتني وجاوبت الاستاذ مصطفى، قلت له المشروع اذا هو جديد وبعدك مرحله التصاميم، هذا بدايه جوابي كان. Olga, the discussion now we're having is about the parameter whether the tower can be elevated. So my answer is obviously if it's a grassroots, not a revamp, not an existing, you can ask this question. But if it's already installed and in operation and you have like kind of revamp project, it becomes very difficult to go to this option.
Yes. Indeed, for our revamp, actually, revamping projects are usually the complicated one, because we have to manage all what it is installed, even if it does not, even if it is not well for what we want to achieve. So if the tower is already installed, then we need to manage. Then if, for example, if what can happen, that the tower is installed, then we cannot elevate the tower, and we need to have more liquid static height. It means we need to have more distance between the column and the inlet of the reboiler, because we need more pressure. In this case, if we cannot have this, we can go to the solution of installing a pump and having a forced circulation reboiler instead of vertical thermosiphon.
Yeah, that's fine. Yeah. So what I kind of answered, we are on the same path. Okay. استاذ مصطفى، واضح الصور الجواب لك يعني؟
اي نعم هسه واضح صار.
نعم.
ممنون.
هو شنو طبعا هذا موضوع الاليفيشن ترى مو بس يتعلق بالريبويلر، يعني حتى المضخه بغض النظر عن موضوع المحاضره اليوم، يعني اذا انت عندك مضخات للاوعيه للفيزلز وللتورات. المضخات وحدها عندنا تعرفون مفهوم ال NHSP اللي هو هذا النت سكشن بوزيتيف فاليو، هذا هم يلعب دور. يعني انت المضخه نفسها بها مرات تصير اشكال بسبب عدم كفايه ارتفاع البرج الى اخره. فالقصه هذا الكلام ينطبق على الشيء الجديد، يعني مثل ما سمعت هسه بالجواب. We've got a question in the chat. It says, I think it's question about, is the sequence of these factors considerable in the selection? If the tube fluid has higher pressure and less temperature than shell fluid, should we keep them as they are or reverse them? أستاذ ضرغام ما أعرف، ممكن توضح لي؟ ما مفهوم يعني إذا أنت شلون إذا عندك ضغط أعلى ودرجة حرارة أقل. أستاذ ضرغام ما أعرف جزء ما عندك مال. In slide 30 he's asking Olga if we go back to slide.
Yes.
So the question is about if we have a higher pressure, he's asking, higher pressure but less temperature than the shell fluid, should we keep them as they are, or I think he meant on the tube side.
Well, okay.
I think he thinks about sequence. I think this is not sequential factors. These are all applicable, right, in one go.
No, not at all. Actually, these factors are the factors influencing the type of the reboiler, but are not, of course, sequential. They are just some factors we have to consider. And I guess that the question it is like, okay, if we have, because here what we are saying that fluids with high pressure, it is likely to place it on the tube side. So then we can avoid having a thick shell, which is highly costly.
What happened, maybe some people, they have this understanding. It's like you go one, and then if it's one is applicable, then you follow two. And no, so there is no sequence. These are the factors you look into when you choose the reboiler type, right? So it's not just, they have to be in a sequence. They are not in sequence.
Actually, this is like a brainstorming, and we put all the factors on the table, and we say, okay, what we have and how we can place all these factors to have the better reboiler construction.
Yeah, okay. يعني استاذ ضرغام هي الفكره انه واضح انه هاي ما لها يعني مو تتابع تمشي، هاي مجرد افكار اللي انت شنو اللي تقرر على اساسه تخلي الفلويد بالتيوب سايد، يعني مو ريليفنت، ما لها علاقه انه لازم انت اذا فولنج هيك فتروح للكروجن شنو، لا هن ذني كلهم انت تعتبرهن في اختيار الفلويد وين يروح على الشل او على التيوب سايد. احد عنده سؤال او استفسار بعد شباب؟ تفضل استاذ مصطفى.
يعني استاذنا بس السلايد 31
سلايد 31
استاذ احنا هنا قلنا نستخدم المضخات اذا كان عندنا الفيسكوسيتي اكثر من 25. هنا اذا هي
لا مو نستخدم مضخات، هذا الدايجرام هو ما يفرض عليك، هو يسألك اذا انت المضخه ما عندك فتقدر ترفع التور، يعني هذا سؤال وليس انه موجود عندك.
لا بس دقيقه. هسه هذا سلايد 28 كاتب اذا الفيسكوسيتي كان اكثر من 25 احنا نقدر نستخدم الفورس سيركيليشن. لان هسه هنا هاي الفيسكوسيتي اقل من 2، ليش اخذنا الفورس؟
اكثر من 2، بالعكس تشوف اكثر. يعني اذا الفيسكوسيتي اكثر من 2 فتقول له يس اكثر فتروح على الفورس سيركيليشن.
مو احنا هناك قلنا يعني الماكسيموم مال الناتشورال هو كان 25، وباكثر اذا اكثر من 25 نروح فورس. يعني هذا سؤال.
لا هو هسه انت كلها جايد لاينز، يعني اذا انت عندك الفيبر اكثر من 30% وتقول له اكثر من 30% احتاج تكوين الفيبر من الريبويلر، فيسألك هل الفيسكوسيتي أكثر من 2؟ تقول له إيه، فيوديك على الفورس سيركيليشن. فذاك هو انكلودد، يعني هذيك السلايد ما تناقض هاي السلايد.
اوكي ماشي. سؤال ثاني استاذ العفو، هنا الانترنال ما يعني الجايد لاين هنا الانترنال وين راح يحطه بالضبط الانترنال؟
وين يعني ما فهمت قصدك؟
لا هسه احنا عندنا النوعيه الانترنال ريبويلر اللي ذكرناه اللي داخل هنا أنا باي واحد من عندهم يعني بهذا الجايد لاين هنا الانترنال يعني وين احطه هنا؟
هذاك هي راح يصير اكيد هم له تصميم، يعني تفهم قصدي؟ يعني هسه احنا ناخذ اول شيء خيار، يا خيار انت تروح له تصميم داخل الريبويلر. كل واحد من ذولا اكيد يعني احنا
هو ابو يوسف بالشرح مال الانترنال راح يلقى السبب اكو موجود. موجود خلينا نرجع للسلايد.
الجايد لاينز مال الانترنال موضوع ثاني، تصميم واحد. هسه انت تروح على
موضوع ثاني وسبب الاختيار موجود بالشرح مالته.
اي يعني اقصد انت تختار اول شيء نوع الريبويلر، بعدين تروح للمرحله اللاحقه اللي هو اختيار الدواخل مال الريبويلر.
رحم الله والديك.
اوكي
يوسف مصطفى يقصد البويلر داخل البرج، هذا الانترنال الداخلي
داخل يقصد
اي ريبويلر داخلي. شلون اختاره من ضمن ذن الخيارات؟
العفو انا اسف.
هنا ماخذ فيرتيكال وهوريزونتال، هو ذاك هوريزونتال بس داخل البرج يعني، فتقريبا هوريزونتال داخل البرج.
So Olga, the question about the reboiler which is inserted inside the column, so it's kind of they asking, it's not shown here, yeah?
Well, actually, the reboiler inserted in the column is an horizontal thermosiphon.
Yeah, so it's part of it.
It's a horizontal type, yes.
Yes, actually. So if the horizontal, if the area is small enough to place the reboiler inside the column, and there is place, because this is another constraint, if there is place inside the column to insert the horizontal thermosiphon, let's go for it, and we will have an internal reboiler. But internal reboiler is part of the horizontal thermosiphon.
Thanks, Olga.
You're welcome.
What's the difference between the bottom pump and force circulation? first هو الفورس سيركيليشن. انت شلون تسوي فورس سيركيليشن؟ تسويه باستعمال المضخه وين تكون موجوده؟ على البوتوم مال التاور. استاذ الجواب عن سؤالك يعني هو باستعمال المضخه سويت السيركيليشن مو طبيعيه مو ناتشرال، سويتها فورست. هذا التعريف يعني. اوكي شباب احد عنده سؤال او استفسار؟ اوكي I think that's it Olga. but شباب اريدكم تبقون لحد يطلع من البرزنتيشن. Olga, thanks so much for your effort and your time. It was very valuable information for today.
Okay, thank